Well, hello everyone. I hope you're doing well. And we start by reminding ourselves of our goal that we set for ourselves before. It was to model the financial market, yeah, and it means that we would like to model riskless asset like bond, risky asset, usually it is stocks, and to evaluate derivatives, yes. And on the previous lecture, we evaluated the price of European options in the multi-period binomial model. But there are not only the European option, but for example, American option and some other kinds of options. So about it, today's lecture. Yes, you see that our overview. You remember how we evaluate the European option in the one period binomial model. After that, we studied the arbitrage theorem. On the previous lecture, it was the multi-period binomial model and Cox-Ross-Rubinstein formula and replicating strategies. And now we are on the 5 points. It's pricing American option in the binomial model. Okay. So in general, about option style. Yes, in finance, the style of option is the class usually defined by the dates on which the option may be exercised. The majority of options are either European or American style options. And these options have the similar payoff. And they, European and American option, referred to as vanilla options. Maybe you have heard these terms, yes? Vanilla, yeah? Vanilla options. or maybe have heard vanilla Coca-Cola, yes? Options where the payoff is calculated differently is called exotic options. Yes, we said that payoff function, it is the key component for the difference, what is the vanilla options or exotic option. Do you remember how we computed the payoff function for our call option in the previous lecture? Do you remember? So, okay, for example, we have the call option with strike price K, and we denote the market price of stocks as sub T. So, what is payoff function? Volodymyr, do you remember?
S minus K.
Yes, it is just like S minus K. S means the market price at the time to maturity, yes, and K means the strike prices. If to say more exactly, more precisely, so it is maximum, yes, between this difference and zero. Because if the market price less than K, it is not profitable for us, and we don't obligate to exercise our option. Yeah, remember? Guys, remember about this?
Yes.
Thank you. Okay, now about difference between American and European style of option. Um, the key difference relates to the date when to the moment when the option can be exercised. European options, you know already, may be exercised only at the expiration date. So you remember we saw the Nasdaq site, and we can see we can see and we can choose the date of expiration, and it was date, for example, 15th of April or 10th of February. So it is concrete date, yes, concrete date. Uh, American option has the concrete date too, but this option may be exercised at any time before the expiration date. Okay, so American option has the expiration date too, but may be exercises before this date. Before this date, and it's clear that for both American and European option, the payoff we can define like maximum between S minus K and 0 for call option, and K minus S and maximum between K S and 0 for put option. Yes, and we already reminded this today. Yes, and we know that K strike price, S it is market price, spot price of the underlying asset. Usually it is stocks. Okay. How to evaluate the fair price of American put option using the binomial tree? Yes, we know how to evaluate the European call option, but what is difference? What is difference? And how we can evaluate the fair price? No, I mean premium. Yes, of American put option. The problem is that we don't have the analytical formula, and it's impossible to get the analytical formula like Rox Rubinstein. Cox-Ross Rubinstein. So we choose the way like for European option. It was backwards. Yeah, remember it is, and it was the similar, but you will see the difference. The difference. Okay, what are given? The given is how to construct the binomial tree. And for this construction, we need to know the initial price as 0. Yes, maybe I can write what are given. It is like as 0, um, and for construction binomial tree, you need to know u factor and down factor d and risk neutral measure. Yes, how to calculate u and d, it will be at the next lesson, u and d, but today we suppose that these factors are given. R, what is R? Do you remember? Olena, what is R? R is given, but it is denoted.
Inflation rate.
Yes, yes. It is like interest rate, yes? No. For example, 1%, 2% from bank, yes? Okay, so we know this, this, and this, and we can construct binomial 3. And how we can construct binomial 3? The initial as 0, yes, and for next moment it's binomial tree, so it should be only two values. Yeah, so what it is values?
Up and down
No, yes, it's
values.
scenario up and down. Yes, you are right. But what is the value of this node, of this point? Or what is the value for stocks? If it
SU,
SU,
S,
yeah, SU, and at this point,
SD.
SD. Thank you. After that, at next moment, it will be this. What is value? So it is rule. It is
SUU.
yeah SUU. So SU square. This it is like SD square. Yes, similar. But
Between will be SUD.
between will be SUD. Okay, SUD. Thank you. And I'm glad that you know this, how to construct the binomial tree. But the binomial tree is defined if we know not only how to construct these values, but how to compute the probabilities to get from this point to this and to this, because these probabilities are the same. So it is two probabilities for any node. Yeah, it is the same. It is like QU and QD and QD. And how we can calculate these probabilities? Risk neutral probability. We can say it me formula, or we can say it me the way how to compute there. It is up to
It
you.
is like 1 plus R minus D divided by U minus D.
1 plus R minus D, no, and U minus D. And its formula for what? It's Q,
Uh, it's Q, yes.
U, no, U, yeah, Q up, yes?
Yeah, yeah.
Q up. And QD 1 minus. But
While, yeah.
yeah. But if you don't remember this formula, you can use the simple rule. The simple rule, it is like the price on the future, for one period model, the mathematical expectation for the future of the stocks. What is the mathematical expectation? It is like S U multiplied Q U plus S D, okay, multiplied Q D. Mathematical expectation equals like we put our money on the bank account, S multiplied 1 plus R. And if we cross S, it should be QU plus UQU plus DQD equals 1 plus R. And if we take into account that QD equals 1 minus QU, we can get this formula. Okay, so it's up to you. We can remember this formula. We can every time compute this. Okay, so step one, um, set or calculate up factor. Now we only can set risk neutral probability. It is QU or Q, yeah, uh, and 1 minus Q. So it's like risk neutral measure. Yes, Q and 1 minus Q, where Q means Q up. Okay, step two. We start with the final time step n and calculate the payoff for each node. No, it is like this. For example, it was this tree, and for this we have points, different points, and we calculate the payoff for each point. And if it is the put option, so you remember this formula, and we can calculate. Yes, maybe it will be better if I show you the example, and after that we will return, we will back. So in this picture you can see 1, 2, 3 binomial, yeah, 3-step binomial 3, and 3-step binomial 3, and suppose strike price equals 100, and the risk interest risk is 1%, yes, 1%. So we construct, we know U and D, and we construct this binomial tree. And the first step for evaluating the American option price, first step, it is payoff function at the time equals 3. And we just apply the formula that this payoff function equals K minus S with plus. With plus, it means that if it's positive, we write. If it's negative, we write 0. Yes. So 100 minus 122, it is negative number, so we write 0. Yes. Okay, 100 minus 107, negative, we write 0. 100 minus 93 and 46 is positive, so we write this value, it's 6.54. And 100 minus 81.63 is 18.37, and we write it. So about the time equals 3, the final time. Everything is clear. Yes, guys?
Yes.
Okay, thank you. Thank you. Oh no, it's not. Clean. And we will back to our steps. So it was the step 2. It was the step 2 on the example. Yes, it is like maximum between K minus S. And step 3, it is the main step. We work backward through the 3. And the value of the option at any node is the maximum of the two values. So the value, yes, of A, American put option is maximum between two values. And what are these values? So what two actions we have? No, I mean to choose for us.
Fx size is K minus S, what we have done.
Now I ask about the opportunities for holder of this American option, because key difference key difference from the European option is that if you are holder of European option, you always wait to the time of expiration, yes? And only on the final moment you can compute this payoff function. But if you are holder of the American option at any node of this binomial 3, you can decide. You can decide immediately exercise this option or wait. Understand? No?
Yes,
Yes.
it is the main difference between this. So we can we can just we have new formula, yeah, for F weight. So we also compute F weight and see what is better,
Yes,
to
yes,
wait or
we
exercise.
need to exercise the price of waiting and the price of immediately exercising. Yes. So this means the payoff if option exercises immediately at this node, and we know this formula. But waiting, the price of waiting, means that it is like a mathematical expectation, discounted mathematical expectation. Okay? Yeah? Understand?
Yes.
Okay, thank you. Oh, no, 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 no. It's clear. So it is on this slide you can see you can see these steps, but maybe in mathematical forms, and for put option for two-step binomial tree, and on the t equals 2 it's payoff function, but on the time t equals 1 it is maximum between this it is immediately realization, yes, and this it is like the price of waiting, and the price of waiting it's discounted mathematical expectation. And when we compute this, if we choose what is maximum, we denote this value like f1 c1, and after that yes, and after that it is a random value because we have two values, yeah, for u and for d, and we work backwards for the initial points. And maybe yes, it is we need to compute this using this binomial tree for this example. Okay, so now now we have payoff function. Payoff function, or it's not payoff function. It is the it is it was the value of the stocks, and payoff function is in a blue color. Okay, blue color, blue color. This blue color. So it is payoff for American put option, and after that we need to work backward, and we need to find out what is value A. What is value A? And we said that value A is maximum, yeah, between two values. The first value is the price of immediately realization. If we in this node immediately realize our option, what will be the price?
In node A,
K minus S.
but in node A, correct?
Yeah. No, yeah. It node A, yes. The price
114.
It is
this will.
formula for American option, but recall not too early. It is a put option. Put option. What is formula for payoff for put option?
K minus S. It is a formula.
Yes,
Or
K minus S with plus, okay? With plus.
Mhm.
It means if it is positive, we write, and if it's negative, we don't write. It is zero. Okay, so K minus S, it is like 100 minus 114, okay? And so what I need to write?
Sorry. So it is then 14.49, then 0 and 0 for not A if we subtract it. Oh,
The
no,
price,
no, sorry. No, I
the,
subtracted not
yeah,
the correct.
the price
Uh-huh.
of immediately realization, it is subtract 100 minus 114.
Yeah, it is 0,
Yeah, it
0,
is zero
and
because it's negative, yes? So we
mhm.
write zero. So the price of immediately realization, yes, we write it as like F, um, how we write? F, what is, no, no, okay. F, no, it's interesting that it will be the same, the same. F exercise, okay. F exercise. So F exercise, F exercise, it is zero. But what is the price of waiting? If we wait, it will be what?
We compute on formula which was given in the previous slides.
A computer
No.
formula, it is like discounted mathematical expectation. And what is this value in blue color? So it is 0
Zero, zero.
multiplied QU plus 0 multiplied QD. Yes? So it is 0. 0 plus 0. And maximum it's 0.
Mm-hmm.
Yes? So it's just 0. So A equals 0.
So now for every, yeah, for like for 114 we compute the same, for 100 we compute the same, yeah, and see like
Yeah,
for up, down, and the,
it is.
okay.
Now we need to compute for node B and for node C. Yes?
Okay.
For B equals maximum between the immediately realization, it would be what?
So it is 0
It is
as
0.
well.
Yeah. 0, and it is price of immediately realization or exercising, yes, exercising. But what is about waiting? It is 1 divided 1 plus R.
And multiplied, now it's not 0, it is 6.54
Multiplied,
multiplied by F
yeah, multiplied by Q.
by 100.
No, не.
No?
It is mathematical expectation. It is a product of value by probability. And this
Okay.
probability Q, QU, this QD, or it's Q and 1 minus Q. It doesn't matter how we denote this, yes? So, for example, Q, yeah, Q, this 1 minus Q, no, or QD, yeah?
Okay, sorry.
Yeah, yes. So we needed to compute this before, but it doesn't matter. And okay, maybe
So we should compute it now, correct?
yes,
The
we
QU
should
and
compute
QT.
it now. And please, Volodymyr, what is formula? Volodymyr, yeah?
Yes.
Uh-huh.
For, it was 1 plus r minus d.
1 plus r minus d. Mm-hmm.
Divided by u minus d.
U minus d. And Vladimir said, what I need to write? 1 plus r. It is this, yes, 1.01 and minus d. What is d?
0.93.
Yeah, 0.93. No, more precisely, and 46, yes, but okay. And what is u?
1.07.
Oh, yeah, and minus 0.93. Okay, and maybe someone can compute this. What's the result?
1 second, I will compute.
Mm-hmm.
I have got 0.57. Maybe someone will check also. They've got.
57, yes?
Yeah.
57, okay. So this we need, if we compute, it will be 1 divided by 1.01, and this 6.54 multiplied QD, but it is QU, so QD it is
43.
0, yes, 43. And what is the result? This multiplied to this divided by this.
I got 2.78.
Same.
2.78.
78.
Okay, 2.78. Okay, so B equals 2.78. And now we need to compute C. And C equal maximum between immediately realization. Immediately realization, it is how much?
12.66.
12.66. Mm-hmm. And the price of waiting, it is 1 divided by 1.01, and mathematical expectation, it is this value by Q plus this value multiplied by 1 minus Q, yes? So it should be 6.54 multiplied by
0.57
yes, you're right, 57 and plus
18.37 multiplied by 0.43.
Mm-hmm. multiplied by 0.43. And what is the result from this? 6.54 multiplied to 0.57 plus 18.37 multiplied to 4 multiplied to 0.43.
I have 11.5. 0.5.
11.5. Okay, so the holder of this option can decide what is better. So he should choose what from these values?
The first one.
The first
The
one.
F exercise.
Okay, thank you. Thank you. So we know for C the value is 12.63. Okay, so all this we computed for t equals 2, and now we need to compute for t equals 1. Yes, it was the same. No, for example, it is node D, yes, and we need how compute it is again maximum between the price of immediately realization. Immediately realization it is 100 minus 107, yes, so it is 0. So it should be the price of waiting, 1 divided by 1.0. And this it is mathematical expectation to get this value a and b, 0 and 2.78. So it will be 0 multiplied qu, it will be 0, and this value, okay, so d it is maximum because the first one is 0, so it is 1 divided by 1.01, and this it is 0, so it is 2, yeah.
Yes, it is 278 multiplied by 0.43, the QT.
0.43. Okay, and what is the result?
1.2.
1.2. So it is D, yes, 1.2. After that, we need, for example, this F, and after that, we can compute the value from this point. And it's interesting that the price of immediately realization 0, yes, again, because this 100 and this 100. So it should be the price of waiting, the price of waiting. Okay. No, this. I would like to clear. So, so you see that maybe it is the same, yes? So on this slide, you can see only how to compute for this node. It was for us ABC, yes? C, it is maximum between the price of immediately realization, yes, and the price of waiting. And we choose the price of immediately realization, yeah. For this, it's 1.26, yes, for this 7.14, and for this it is exactly the maximum between the price of immediately realization 0, so it will be the price of waiting, 1 divided by R, and Q multiplied 1.26 plus 1 minus Q multiplied by 7.13. Is it clear how to compute the price of American option by workbot? Yeah? Yeah?
Yeah, at this point we are simply moving backwards.
Okay, thank you. The task for you will be to compute this using Excel. Okay. And the second questions about the pricing and American option is, no, the first question is how to evaluate the price of American option, fair price. Yes, it is this 3.82. And the second questions, how we can obtain an appropriate time to exercise the option for the maximum payoff. Now, for example, if we know all this, what do you think? What is the appropriate time to stop? To stop. It should be when the price of realization, yes, immediately realization is more than the price of waiting, yeah?
Yes, it's logical.
It's logical. And the answer for concrete example is it is the first moment for this. The first moment. So for example, this, yes, it is the price of realization more than the price of waiting. But it is at the moment t equals 2. But I don't remember, maybe this, yeah, maybe this, yes, it is 100, yes, some 100. So at this note, the price of immediately realization more than the price of waiting too. But it is the first moment, yes. So the answer for this question is t equals 1. T equals 1. If we are in this point in the down scenario, so we need to stop. Understand? Yeah.
So we take t equals 1 and we stop because of the values we got, yeah?
Yeah, because this the price of immediate realization 7.13 is more than the price of waiting. The price of waiting, the mathematical expectation, is the price of realization more than the price of waiting. Less, the price of waiting
Can you
less.
please ask what is the price of waiting here? So 7.13 is more than
Then this. No, we don't compute this, but we know exactly that it is more and less. So this answer.
But to find it all, we should compute as we did before, to compute all these
Yeah,
three nodes, and then we see that it
yeah.
is forced to stop at t equals 1.
Yeah, so yes, we need to compute, yes, this value in all node, and we need to know what will be more and what less. And the answer is that if it t equals 1, we are in the down scenario. Yes, so it's time for stopping. Yeah, it's called, it is the optimal time for stopping. It is the optimal time for stopping. Okay. And now it is like similar time for stopping a simple dice rolling game. Yeah. Do you like to play in the game? And maybe you know this game. Yes. You can throw a fair six-sided die up to maximum of, for example, 3 times or 2 times. We start okay, we from with two times, but before about rules for this play. After any through, you can choose to stop or to continue. If you stop, you get an amount of money equal to the value you threw. For example, if it is 4, if it is 4 on the up, yes, you get you get the four, no, I don't know, 4 euro or 400 of euro or 4,000 of euro. It is it is like you agreed before, okay? But if you don't stop, you can say, I continue. After that, you through again, and for example, it's 1, and you say, oh, I want to continue again. And if the third time it is, no, for example, again 1, uh, you don't need to say anything because it's end of game, okay? Because you have, no, for example, only three attempts. But if first time was 4, you could say that stop and get this for thousands or for 400s. Is it a good game for you? What can you say? Do you want to play this game? Do you want to play this game? What can you say? Mikhailo.
Yeah, so if I write in this game, if you at the second, for example, at first we get 4, and after that we must get 5 or 6 to play in this game. Am I right?
Yes, you're right. No, but
Because I don't know. I don't
maybe
understand the rules. No,
the rule.
why?
Okay, Misha, we can after 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 each through, we can decide if you want to continue or you want to stop, but you don't know what will be the second time. It is more than now, or it's less than now. Yes, and anyway. Um, Anyway, is it a good is it a good play for you? I mean, for me, yes, because I see and you see that it is a riskless game. Yes, every time you get from 1 to 6. Yes, so I think it's very good game. But maybe you can say something for me, Olesa. Olena Pasternak.
It's all right. Okay, so personally, I would like to play this game too because we don't need to spend money for the throws. Like, there is no deposit. And after we get 4, the probability of getting bigger numbers is smaller than the probability of getting smaller numbers, so we should stop at this point. Yeah,
Yeah. So.
otherwise for 5 and 6 too. Yeah.
Yes. So now I didn't ask you about algorithm, but maybe you are right. If you see that it is 6 or 5, so it's need to stop. Yes. No, for example, yes, I think. I would like to ask you, but who made to organize this game? I think no one. Yes, because because if someone organize this game, he need to pay everyone, yes, from 1 to 6.
Yeah.
So you are right. Maybe it's not free game. Yeah. Do you
Yeah.
agree that it can be? Yes. So there is a fee for this game. Okay. So the first question, what is the fair price for this game? Yes. And the second question, what is the algorithm for these games? For you, like for gambler, what is the algorithm? Yes. And it is first point, and the second point that it is game isn't free. Okay, and now we need we need to formulate the algorithm, but it's clear if the 6 we need to stop. Yes, yes, guys.
Yes,
Yeah.
because
Yes, and 5 maybe too. But what is about 4? No, I don't know. And we need to apply mathematics, probabilities. Да? Okay. So, for the answer for these questions, we work backward again, like 4 options. And like 4 options, and so we start from the last attempts. If we have, for example, two attempts, two attempts, two attempts. So the last attempts, it is what is the mathematical expectation for the last attempts? We can get 1, 2, 3, 4, 5, and 6 with probabilities. What is the probabilities for 1?
equal probabilities 1 divided by 6.
Yes, all probabilities is 1 divided by 6, yes? From 1 to 6, yes? This, this, and this. So mathematical expectation for the last through is how to compute mathematical expectation?
1 plus 2 plus 3 plus
It's
4
4.
plus 5
It's
and
4.
6 divided by 6.
Yes. So 1 no, yes, it's my 1 multiplied to this plus this multiplied to this, but
Yeah.
it is 6 like in the denominator, 1 plus 2 plus 3 plus 4 and plus 6, and it should be 21 divided by 6. 21 divided by 6, it should be how much?
3.5.
3.5.
Yes, thank you. 3.5. Oh, so we know the mathematical expectation at the last attempts. Yes. So if we have only 2 attempts and we threw this die and we see, for example, 6, it is stop. We decided to stop. 5, we decided to stop, and 4. What is about 4? If you see
We should
4,
stop.
yeah, we need to stop because the price of waiting, yes, it is 3.5. But if you see 1, 2, 3, yeah,
We
1, 2, 3,
continue.
we continue. So the mathematical expectation for this, it is like for the no 2 attempts, it is like for first, if we know what will be in the 2, it will be so if 1, 2, and 3 we wait, yes, so 1 multiplied by 3, oh no, sorry. Mhm. So if you see 1, 2, or a 3, yes, you decide to wait. So it is like the price of waiting 3.5. So it is for 1, it is 3.5. If you see 1, I decide to wait and to get 3.5 with the probability 1 divided by 6. If I see 2, the same, 3.5, it is price of waiting, multiplied this. No, it is the probability, no, 2 and 3, it is the same, yes? Multiplied at 1 divided by 6. But if you see 5, it is stop. So 5 multiplied by 1 divided by 6, and 6 plus 6 multiplied by 1 divided by 6. Okay, so it is 6 in denominator, and this it will be this plus this plus this plus 5 and plus 6. Okay, we can it's on the next slide, should be. Oh, yes, you see. So 6, 5, 4, 5, and 6 stop, and to this wait. And in the result, it is 4.25. Do you understand? But suppose you allowed 3 throws. So now, if you see, so you can see, sorry. Now you can see again 1, 2, 3, 4, 5, and 6. And what is the algorithm for this time? If 6 stop, yes, stop play, 5 stop, 4
I should continue because 4 is
uh,
smaller than
yes,
4.25.
Okay. And after that, we need to compute this. Yes, because the price of continuum more than 4. Yes, more than 4. So how we can compute? No, all this, it is the price of waiting for 1, 4.25, for 2.25, for 3.25, for 4.25, and for this it is like 5 and 6. Okay, it's a very famous task, and I know it should be given in the bank interview, for example. Yeah, do you have any questions about this? No, yes. Okay, so in general, if we are speaking about the optimal stopping time, we can denote the value of continuing process by V and value of terminating process, no, stop process, yes, F from xt. So the optimal stopping time we can express like infinitum in infinitum moment when this process, continuing process, less than process of terminating. No, it is like the price of immediately realization more than the price of continuum. Yeah, it is the same of what we already know, but it is like the mathematical expression. Okay, and now about exotic option, because European and American options are called, do you remember how they called European and American? Do you remember?
Vanilla?
Vanilla, yes,
Vanilla, okay.
vanilla. But now about exotic option. Exotic option, it is there are 5 types. It is like quanta, binary, loopback, Asian, and barrier. No, maybe more than these 5 kinds. For the exotic option, the payoff at maturity, да, payoff of exercising depends not just of underlying instrument on maturity, but on its value at several times. Now I will show you what does it mean. Yes, it's like this. It's mean, for example, if it is Asian option, he depending on some average. Look back option depending on the maximum or minimum. A barrier option, it is like a certain level is reached or don't reached. No, you can see more precisely about this. For example, Asian option, yes, you remember that for European and American option, the payoff it is the maximum between what? Sophia. If it is American option or European option.
Can you repeat, please? Sorry.
If we have American or European option, so payoff function, it is the maximum between. How we can write this difference?
Put strike and call strike.
Strike, it is this.
It is S
Yeah.
or
Yes, you're right. It is like ST minus chi. It is the market price at this moment T, yes, minus K. And that's all. And it's vanilla option. It is your function for vanilla option. But for Asian option, instead market price, we use the average price. Yes? Average price of all moment from 0 to t, okay? Okay. The next, it is barrier options. It is like we propose some values like h. It is value like a barrier, and for example, today the price S, and at the moment T, yes, no, it should be different, yes, trajectories, different paths. For example, the K, it is this. The case, for example, this K. But it is K. But we need to give not only K, but and H can be more the can and less the can. For example, it is H more the can, but maybe the price will be this, and after that this, and at time no, yes. So it is we need to know when the market price first time was more than H, not the K, but some H. Okay. No, it's more complicated, but it's interesting to know. And this digital option, it is when the payoff function not like difference, but if you win, if you guess that the market price will be more than K, you get 1. If not, 0. Okay. Not ST minus K, yes, but only 1. So summary, we can say that the valuation of barrier option can be tricky because they are path dependent. That is, the value of the option at any time depends not just on the underlying at this point, but also on the path taken by the underlying. It has crossed the barrier, a barrier even has occurred. The classical Cox-Rosa-Rubinstein or Black-Scholes approaches, Black-Scholes we will study later, doesn't directly apply, but several more complex methods can be used. So if you are interested, you can choose, for example, it is like the topic of your diploma work, okay? So summary, American option pricing, we studied today how to evaluate American option pricing by working backward. We learned what is the optimal time for stopping, what is this, and the payoff function for different exotic options. And reference the same, it is the book John Hall and the Sheldon Ross. Okay. Okay. Do you have any questions?
No.
Okay. If you don't have any questions, so Olena has.
Okay, so you have told that we will do an example in Excel. Will we discuss it on our practice or not? Because I'm trying to do it now, yeah, at this point.
You ask about this practice for today?
Yeah, we have this
No,
American option pricing.
I'm not going to show you how you need to do this in Excel.
Okay.
Okay.
So we have to, explore by ourselves. Yes, the Excel.
Yeah.
Okay.
Because no, yes, I think that you're familiar with Excel. So the formula.
Sorry, is it okay that I did it with Python, not Excel?
Okay, I agree. Yes. Okay, so now you have a time maybe for the applying the test, and we meet at 3 p.m.
Okay.
Okay,
Okay.
see you soon.
See you.
See you.